So in this video I want to make a calculator, or more specifically a binary calculator. Now it's actually quite interesting as it uses logic, and I quite like using logic. I find it fun, but it's also quite confusing. So this was me trying to make a toggle at the start. Now I didn't really need this in the end, and I don't know why I was making it in the first place. But anyway, let's start on the actual calculator. Now obviously where to start. Now I thought of making the interface first so you can actually input stuff and output stuff. Now this calculator is hopefully going to be able to subtract and do subtraction and addition, and hopefully one day obviously multiplying and dividing. Now I didn't exactly know how this I didn't know how I want this to look, but I kind of just decided that it just needs some inputs which are going to be right next to each other, and then there's going to be an output on the other side, which is pretty simple, and also a little screen showing you what you're doing, addition, subtraction, or whatever. Now I did realise that addition is actually quite easy to make. It's actually quite simple, but I still can't really explain it, since there's basically only three things that can happen when you add. In binary at least, as binary is very simple. In fact, I'm not great at binary, but I understand it better now than before. But it's pretty simple, and I can't really be able to explain it, as yeah, I don't really have much time for that. So anyway, now as you can see, binary is obviously not like it doesn't obviously display the number. It's just uses on-off signals like logic gates, and that's why it's actually very useful, and that's why we're going to be using it. And it also makes adding a lot easier, as adding binary is very simple. So first I was actually going to work on the interface, as I was kind of trying put off actually making adding for as long as I can. Now I'm obviously going to be doing addition first. It's the first thing it's normally the first mathematical thing you learn, and also it's generally just sounds like the simplest. And I did actually have a good idea to do it. When you add when doing addition is actually pretty simple, especially adding 1 and 1. Now I know it might sound stupid, but adding 1 and 1 is very simple. So if the maximum number we can add is 1, and the minimum we can add is 1, well, technically the minimum is 0. 1 and 0, 1 plus 0 equals 0, but 1 plus 1 equals 2. So you can probably find out that needs an AND gate. If you add 1 and 1, then it equals 2. If you add 1, then if you add 1 to 0, then it just equals 1. Now that doesn't really explain how I'm actually going to do this, as adding 3 plus 1 is a bit more confusing, as that equals 4. But we've got to do a few more logic gates, because basically if I just use this AND sequence, then it would basically think that 3 plus 1 equaled 2, which is obviously incorrect, as it equals 4. Now, although this seemed very hard in my head at the start, it seemed a lot simpler, and then also got a lot harder, as I realised I need to add quite a few logic gates to make everything work properly. As I'm not actually using any outside resources like websites to do that addition. I did do that for the subtraction, as it's generally a lot easier. Eventually I did get to something which I can just replicate pretty easily in a scalable system. But anyway. Now this did require a lot of logic, and also basically you had to wire a lot of things, and definitely when copying over, this was the worst thing about it, as yeah, wiring logic a pain, especially when there's a lot of it that needs to be wired, and also it kind of looks like spaghetti after a while. But anyway, eventually I got a version of logic which I was quite happy with, so I was going to start duplicating it so I can attach it to the actual machine, because I don't really mention this, but this isn't actually on the calculator yet, as it's much easier to prototype stuff before attaching it, as that means you can easily change it, and yeah. Now, I did have to rewire and add a few more logic gates, obviously, to fill in some gaps, but it wasn't actually too bad at all. Now, I think my logic is probably definitely bigger than I basically think there's a better way to do it. This probably isn't the better way, and it is very very annoying to wire, since I had to spend around half an hour just attaching it to the machine. Now the inputs were quite easy, but the outputs were a pure pain. Because basically the problem with the outputs is that, although, well, there's just many problems with the output. I could have made the output a lot simpler, but I didn't, since one of the things I want to do is make sure this doesn't have too much delay, as if it takes a long time to do math problems, then that's boring, and I obviously don't want that. And if I did do it in a smarter way, it would just take longer. So I think it's good enough. And having wired it up, it mostly worked, kind of. I had to go through it quite a lot and troubleshoot it as I made wrong connections. I think it might have been wrong from the start, so I had to make quite a few things. But it ended up alright. But yeah, now we can add, kind of. As you can see, that 8 plus 4 plus, sorry, 12 plus 4 equals 8, which is wrong. And that's a kind of problem. But it's pretty simple to fix. We just hook up another logic gate and it should work. As you can see, it's kind of quite a mess. It's definitely going to be more of a mess by the time we finish. Now, I never said this thing was going to be small, and it's not. I also added these notches here so you can more easily tell what the answer is. And as you can see, it does not work. At least I don't think it works. But anyway, if we do addition, we should be able to add now. So that is 5 plus 16, 17 equals 22. I'm taking that says, yeah, that says 22 in binary. So yeah, it works. Now I can do quite like complicated things, but it definitely works, and that's the thing. And there's barely a delay to it, which I like. And hopefully hopefully subtraction is just as good, as this was actually pretty easy. And we can add stuff. Now I'm not checking any of these are right, because I'm actually doing quite a lot of math problems, and might take a long time to read binary. But anyway, I started on the subtraction. Now for now we're just working on the interface bit, so we can actually get the bit from subtraction into the interface more easily when I actually do it. So I can more easily display it. But anyway, I did use a website for this, I'll admit that. Now, I'll link it in the description or comments, whichever one I choose, and because it would be real help. And I basically just copy a diagram as well as just read some stuff, and it's very useful if anyone else wants to replicate this. So yeah. Now every time I stand still, it's usually me just going back to the website having a look. But it's actually quite interesting, and it's actually really simple. I'm glad I did this, as it meant that I didn't have to make my own system, which would have not worked very well. And I'm not even going to try explaining it. Well, actually, I can. Basically, there's these half subtractors, and we need 2 half subtractors for a full subtractor. Each full subtractor lets us do another digit of subtraction. So if we have one full subtractor, we can do 1 minus 1. If we have 2, then we go up to 3 minus 3. And if we have, yeah, it's a bit interesting. Now how it works is just has an output to the screen, and also a borrow output where it borrows stuff, like you wouldn't in subtraction, as you need to borrow stuff, because if you're doing, I don't know, like 56 minus 48, then you're going to need to borrow 1 from the 5, so it's going to be, yeah, I don't know how to explain it, but it works, basically what I'm saying. Now this is the full thing. Now my last one was very big. I did also colour code it so it's easier to learn, but the green is basically the borrow bit, the red and blue bit are the inputs, and as you can see there's 2 of them. but it works. Now this is just, I can't even tell what I'm doing, but it does work. As you can see, it's being a bit weird, and as you can see, there's a serious delay. Now I hope there's not so much a delay on the actual machine. We'll see. Now this was generally a good idea to use a website, as look at this, we can definitely, well, this is generally a lot easier to read, even though it might not look like it. There is just one output from each full subtractor, so it works. Well, it should work. So if we do, now there is one problem, is that the fact that you can still do negatives, and what I mean is that output can be negative, it just doesn't tell you it's negative, but it's kind of obvious, because if you put a note, if you did, well, 5 minus 10, it's obviously the answer going to be a negative. Well, I hope it's obvious anyway. But anyway, this thing does work pretty well, I'd like to say. I'm actually quite happy with it. Now, there is a lot more to do, I do get that, but this is part 1, and also my next video probably won't be part 2, as I'm going to go back to the AI cars. I know I'm starting a lot of videos now, since I've already got part 1 for AI cars, but I've got some more motivation for them now, so I think I'll do that first, just so I can have a bit more motivation for this when I try it next time. But anyway, it works pretty well, so I'm actually quite proud of it. So I'll see you in the next video.